Okay, now I want to find the equation of the tangent line to the function at this x value, x equals 1. Okay, so to find the equation of the tangent line, let's think about it. The tangent line is a line, right? Which means I need a slope and I need a point. Okay, so this is throwing it back to, y equals mx plus b and point slope form and things like that. So what I need to do is we need to find the slope of the tangent line and a coordinate and a point on the tangent line. I'll just say that, and a point, the tangent line, to write an equation. Okay, so we need the slope of the tangent line. Let's just go back to emphasize this. So we need to find the slope of the tangent line, and we need to find a point on the tangent line. All right, and those are the two things I need to write an equation of a line. Right, because what I'm ultimately going to use is point slope form. I'll recall that in a minute. But that's what you need to do, okay, to find the equation of a line. Okay, so now I'm just going to find a point on the tangent line, all right, because that's the easiest part to do before I even start trying to do slope here. Okay, so what I'm going to do is I know that if I have the equation of the tangent line to the function f at x equals 1, then I know that at x equals 1, that's a x-coordinate, that's a point that is on the tangent line, okay? Because I'm drawing a tangent line through that point x equals 1, and so x equals 1 is a point on the tangent line. But what I want is a coordinate. So here, I'm going to find my point, which is 1, comma, f of 1. Okay. And so I need to figure out what f of 1 is. Well, f of 1 is just 2 times 1 squared plus 3 times 1. And so this is just going to be 2 plus 3, which is equal to 5. So beautiful. My point here that I have, or my coordinate that I have here, is 1, comma 5. Okay. So now I want to find the slope of the tangent line. So what is the slope of the tangent line at x equals 1? What's another word for the slope of the tangent line at a point? It's the derivative at that point. Okay, so the slope of the tangent line at x equals 1 is equal to the derivative at 1. Okay, and so ultimately now what I need to do is I need to find the derivative function and then plug in 1 into the derivative. And then that will give me the slope of the tangent line. So here I'm going to find f prime of x. Okay, and so I'm going to look at my function now here. And I'm going to find the derivative of that function. So we know that the derivative of my function f is going to be the derivative of the first function plus the derivative of the second function. Because see how it's a sum of two functions? Okay, so now this is going to be copy my constant times the derivative of the function plus the derivative of 3x is just 3. So now I have 2 times the derivative of x squared, which is just 2x, plus 3. And so this is just going to be equal to 4x plus 3. Okay, so now that means the derivative at 1 is just going to be 4 times 1 plus 3, which is equal to 7. Okay, because now I need to just plug in 1 where I see x into the function, all right, to find the derivative at 1. And so going back, this is just going to be 7. Okay, so now I have all my key components here, because I have my point, okay, my coordinate 1, 5, and I have the slope of my tangent line, which is the derivative at 1, which is 7. Beautiful. Okay, so now I want to recall point-slope form. Okay, so that was y minus y1 is equal to mx minus x1. Okay, so beautiful here because I have my x1 and my y1 when I go back to that coordinate, right? And I have my m. This is my m, see, because I have that my m tan, or my slope of the tangent line, at x equals 1. That's just going to be 7. So now I'm just going to plug in all of these numbers here into this equation. So I have that y minus my y1, which is 5, is equal to m, which is 7, times x minus 1. And then that's all I really need. Now, if you want to put it into y-intercept form, you just solve for y. So solve for y if you want to put it, in y-intercept, slope-intercept form. Okay, so here you would get that this is y minus 5 is equal to 7x minus 7, and then you'd add over the 5, so you have y is equal to 7x minus 2. Okay, so to be honest with you, I'm completely fine if you left it like this, in point-slope form. But if you want to, and that's possible, that could be an option on the EP exam, where it's in slope-intercept form, you need to understand how to go from point-slope to slope-intercept by just solving for y.